hopefully with a little bit more detail. Yeah, I've worked at the Johnson Space Center now almost for 30 years, starting as a co-op in 1985. And I actually got involved in ISRU because of your sample return mission concept that came out of Lockheed Martin. I think that was in '94 timeframe. The interesting aspect of it was that, and I digress, but I think I had the time. In 1992, a study was performed for a Mars sample return mission that required two Titan IV vehicles. One to land a large rover to go grab some samples, the other to land a fully fueled ascent vehicle to bring those samples home. Forward 2 years, and Bob Zubrin proposes that a sample return mission can be done with a single Delta tube launch vehicle. That got a lot of people's attention. So for the first time, the Johnson Space Center on the engineering side decided to take a look at it, and I worked in the propulsion branch here, chemical propulsion. And it got to the point where, up to this point, the ISRU work had been done on our science side for a large number of years. And I was tasked with designing the landing propulsion system and the ascent propulsion system. And they looked around and they said, well, who at Johnson in the engineering directorate knows how to make anything about the propellants? And they said, well, you're going to use them, you figure it out. So that's kind of how I got involved in all of this. And as Bob kind of mentioned, you know, NASA goes in fits and spurts, and so a lot of the work that you're going to see has been done over this time frame. Let's see. So I always like throwing this chart up to kind of make sure that we're all on the same page. INSITU resource utilization basically involves hardware and operations that harness and utilize in-situ resources to create products or services that can be used for robotic or human exploration. And I use in situ loosely because our unofficial logo for ISRU and NASA is a vulture, based on the fact that trash or waste or whatever anybody else throws out is a resource just as much as the atmosphere in Mars and water ice at the lunar poles. We typically break this down into 4 or 5 different areas of research. The first being making sure we understand what those resources are. Basically, you know, prospecting. Go out, characterize, map, make sure that the resources are there, they're in the form that you expect them to be, they're in the quality and the quantity that you hope that to use. Basically, mining principles 101. Once you have an idea of those resources, there are several things you can do with it. The one that we are primarily interested in is mission consumable production, making propellants, life support consumables, fuel cell reactants, things that get used up. And as Bob pointed out, you know, launch vehicles are primarily propellant, chemical propulsion stages, and such. So then, but there are other things you can use it for. Civil engineering, surface construction, making roads, landing pads, berms, habitats. Some of these things are actually very important when you start thinking about going back to the same location over and over again. I had the opportunity to go to a nickel mine in Sudbury, for example. They build roads a mile deep under the surface to get to the ore body face. They don't do that because they like to build roads. They do that because it cuts